Hello, welcome to Brahma's Notes, and in this kind of videos we shall be going through notes of different topics, and today we shall start with electrolysis, and I believe by the end of such videos we shall be able to correctly attempt questions concerning electrolysis. Electrolysis is mainly divided into two parts: qualitative and quantitative electrolysis. With qualitative electrolysis, we shall mainly be dealing with ions, the cations and anions. However, for quantitative electrolysis, we shall be dealing with number of moles of electrons and then trying to find the amount of electricity that is passing through a given circuit. However, in this video, we are going to mainly focus on part 1, which is qualitative electrolysis. And we are going to start with a virtual experiment to investigate whether electricity can pass through different substances or not. So, to investigate the conduction of electricity by a variety of substances, we might already be having some theories concerning such investigations. We shall start with the apparatus. We can have solids like magnesium in terms of metals, copper, and so on. We can also have solids in terms of non-metallic substances like rubber and plastic. We can also have solids as compounds like salts. Sodium chloride can be an example of a salt in solid form because we are looking at solids, sugar, and so on. The other substances we can test whether electricity can pass through them could be liquids such as water, alcohol, urea, urine, and many others. As long as it's in liquid form, we can also use it and test whether it will conduct electricity or not. Third, we can have aqueous solutions. Basically, you get a substance and then dissolve it in a solvent. In most cases, we shall dissolve it in water, and for aqueous, we shall be dealing with water. For example, salts. In our first part, Roman 1, we saw salt in solid form, but in this case, we are talking about sodium chloride solution because we are looking at aqueous solutions. So all these salts are being dissolved in water. So we also have copper 2 sulfate solution. We can also have silver nitrate solution, aqueous. So all these can be tested to see whether electricity can pass through them. Other examples of solutions can be strong acids like hydrochloric acid and so on. We can have weak acids like ethanoic acid. We can also have strong alkalis like sodium hydroxide solution. We are dealing with solutions now. Remember, sodium hydroxide can also be in form of pellets, that is to say in solid form. So potassium hydroxide, aluminium hydroxide, all these can be in aqueous solutions. Then lastly, you can have a weak alkalis like ammonia solution. So we are going to use our virtual theory to try and see whether these substances can conduct electricity and then try to come to a uniform conclusion to see which of these substances actually conducts electricity. The previous page we looked at the different substances that we shall try to virtually investigate about, and we said that those substances could be in three forms. They could be in liquid form, they could be in solid form, and they also could be in solution form, that is to say aqueous. And now we are looking at the different equipments we can use to set up this setup. So we need a beaker. This can be our beaker. We can need two graphite rods. Here you can have graphite rod 1 and then graphite rod 2. Then we shall need two crocodile clips, basically to attach the wire to the rods. So here we have our wire, and this is how a crocodile clip works. It just aids the attachment of the wire to the rod here. We shall need a direct supply of current, that is to say direct current supply, and then we shall need a lamp to try and see whether electricity is passing through this circuit. We shall need a switch just to control the flow of electricity. So this will be our switch. So to aid what I'm trying to explain here, this is how the setup could look like. Here we have our DC supply. Maybe we might be having no switch. Our crocodile clips will work as the switch. Here we have our beaker. Here we have our pencils working as the graphite rods because they contain graphite. And here we have the substance under investigation inside our beaker. So this is how this setup looks like. So a better image could also look like this to show you what exactly we mean. Just that maybe this image is quite detailed, but we shall try and look at it later on. But in this case, our electrolyte solution will be the substance under investigation. So we shall come back to this image as we proceed slowly. So test the conductivity of substances in the list above. And the list above, we mainly had the solid, liquid, and the aqueous substances. Solids, we saw salts like sodium chloride in solid state. Liquids, we saw some strong acids like hydrochloric acid. Then aqueous, we saw some salt solutions like still sodium chloride solution, aqueous. And see, in each case, observe the bulb. So what we mean by this is that in our setup, the substance under investigation will be put in our beaker, and then if the bulb lights, then we can say that the circuit is complete, and at that point it will mean that actually that substance is a good conductor of electricity. So once you close the switch and the substance conducts electricity, the bulb will have to light. However, if the bulb does not light or glow, it will indicate that the circuit is incomplete, which means that that substance is a bad conductor of electricity. So we shall try and look at the different substances which will actually enable the bulb to light and those that won't. So something to note is that for solid substances, simply attach the crocodile clip to the ends of the specimen. As we had seen, our crocodile clips were being used to attach the wire to the graphite rods. However, because solid substances can't easily be placed into the beaker, or if they are, then we can directly attach the crocodile clips onto the substance under investigation. However, for liquids, like we have seen in our previous image, these clips are attached to the graphite rods as I had tried to explain earlier. So what could be the observations if at all all these experiments could be carried out physically? One thing we shall note is that the bulb will glow brightly for some solids. Basically, all metals could cause the bulb to light or glow. However, some solutions could do so, but dimly. Some solutions could cause the bulb to light, but not as bright as others. So we know that metals actually contain delocalized electrons that can easily move around. So because of these electrons, we know that metals can easily conduct electricity when we attach the crocodile clips to their ends. However, some solutions could do so, but the brightness of the bulb could not be strong, so we say dimly. However, some solids like rubber and some liquids will not allow the bulb to glow, meaning they will not conduct electricity. And with that, we can come to a conclusion under our results section and have a general view on which substances actually conduct electricity or not. But you at home, you can also try it. Maybe you get a piece of wood, get your crocodile clips. You can get your piece of wood, if this is your piece of wood, get your crocodile clips and attach them at the opposite ends, if these are our crocodile clips, and then connect them to a bulb and then to our direct current. So if your bulb does not light, if this is your piece of wood, and then this is your crocodile clip, if this bulb does not light, then that means the wood does not conduct electricity. So results will show that, or they showed that all metals are good conductors of electricity. That is true. They have free electrons. Ionic compounds in solid state do not conduct electricity. We had a look at our salt, ionic compound, salt, sodium chloride, in solid state will not conduct electricity, even if it's ionic, but once it is a solid, because the forces of attraction between the sodium cation and the negatively charged chloride ion will be too strong for it to conduct electricity. So in solid state, ionic compounds do not conduct electricity, meaning the bulb does not glow or light. Then ionic compounds in solution form when dissolved in water, for example sodium chloride aqueous, or when molten, if we heat and melt our sodium chloride in liquid form, actually they will then conduct electricity, because now the ions will always be free to move within the liquid. So these ions can conduct electricity. Then second last, covalent compounds are bad conductors of electricity. We know that basically covalent compounds are usually molecules, they are not ions. So they are bad conductors of electricity. So the bulb will either fail to light, or it will dimly glow. So they are poor conductors of electricity. The same applies to weak acids and alkaline solutions. Together with water, they conduct electricity weakly. Yeah, some people will say pure water will not conduct electricity, but a better version could be it conducts electricity weakly.